example is a pretty tricky one because you really have to think about the different domains and ranges for the different parts of the function. So the first thing to look at here is what's inside the bracket, and that's negative inverse sine of x. Now we know that for inverse sine of x, we know two things. We know that our domain has to be in between -1 and 1, so that's for x. And we know that our range has to be between -pi on 2 and pi on 2. What that means when we think about it is that this entire function, the biggest that this entire function could be is pi on 2, and the smallest that it can be is -pi on 2. Okay, that tells us about what's inside this bracket. So if we do a little bit of a substitution, just so you can see it a little bit more clearly, let u equal inverse sine of x, okay, and actually let u equal negative inverse sine of x too, so we don't even have the negative. So that tells us that y equals cosine of u, okay, cosine of u. Now, because we know what u can range between, okay, we now can use those values, -pi on 2 and pi on 2, in this function, okay. The only thing that we need to be careful of here is that cosine has been restricted in its domain as well. So for cosine, so far we actually have that u is between -pi on 2 and pi on 2. That's our minimums and maximums. Remember that u is the value that this can be. This is inverse sine. But we have a restriction. And the restriction for u is that u actually has to be between 0 and pi. Now if we think about this on like a number line, okay, there's 0, there's pi on 2, there's -pi on 2, and there's pi. What we're allowed to have is anything in this sort of blue region here. But what we actually have with the function that's inside the angle here, the maximum and minimum that it can be, it's currently in between -pi on 2 and pi on 2. Now to see what we could actually use then, that would be anywhere that we have an intersection. So what we can use and what we actually have. So what we can see here is, you see we've got an overlap here just in this section. So that means that we can only say that u, okay, so what's inside here, u is only going to be able to be between 0 and pi on 2. That's going to be our real limitation. So our actual restriction, we are really restricted to u in between 0 and pi on 2. And that's just as an interaction between the two things, the restricted domain that we were given and the actual values that are restricted here by the fact that we have an inverse sine, and that's limited in the values it can be. Okay. Once we've got what u is, we can now find our domain, and because the question's asking for an implied domain, it's interested in x, okay, and it's also interested in y for the range. So for the domain, let's put u first of all. We know u has to be between pi on 2 and 0. Now remember that u is actually the inverse sine of x. So I'm going to substitute that in. Negative inverse sine of x is greater than or equal to 0 and less than or equal to pi on 2. Now I'm going to take a negative, divide both sides by negative, so we're going to end up with 0. Flip the sign around with sine inverse sine of x, flip that sign, -pi on 2. And now what I'm going to do is take sine of both sides. Now when you take sine of both sides, what that does is it removes the inverse sign from the middle, because sine and inverse sine are opposites, so they cancel, so you'll just have x in the middle, and then we have sine of -pi on 2. Now thinking about the unit circle, -pi on 2 is here, 0 is here, so we know this would be 0 and this would be -1. So I'm just going to rewrite this a little differently. Our bottom value here is the smallest one, -1 up to 0, and that's our domain. Okay, so our implied domain is for x between -1 and 0. So for the range, to finish off, what we need to think about here is u. Now going back to this, u is the angle in here, so it's inside cos, so we're actually looking at y equals cos u. U can be between -pi on 2 and pi on 2. So if I just get rid of a little bit of this here, there should be enough room, you can see we're looking at between -pi on 2 and pi on 2, which is actually this region over here. So, and because we're interested, think about this as u and y rather than x and y, because we're interested in what cosine can be, We know that the most that cosine can be for the unit circle is here, which is 1, and the least it can be is here or here, which would be 0. So the range for this particular function as well, in terms of y, because y is the range, is anything over this side that cos can be, which maximum is 1 over here and minimum is 0. So our range is for y is an element between 0 and 1. So we've got two things here that are important. The implied domain, which is in terms of x, and that's between -1 and 0. The reason for that is that we needed to make sure that we had a compatible region in here that was in between what is the acceptable range of values for this inverse of sine and also the restricted domain. If you didn't have that domain restriction, this would be an easier question because you could just straight up work from this, okay, not have that extra step here with the additional restriction. Once you've found that with u, and we've let this equal u, find out then what the restriction is on x. That's your implied domain. And your range, you're considering this equation here, y equals cos of u, because you've let this equal u, and you're thinking, okay, for u between these values, what's the maximum, what's the minimum that cosine can be? Okay, and we know that the maximum minimum that could be would be 0 and 1.